All right, so we're looking at 6.2 today, the binomial probability distribution. So binomial probability distribution is a discrete probability distribution that describes probabilities for experiments in which there are two mutually exclusive outcomes. So don't forget mutually exclusive outcomes. Talking about outcomes that do not have anything to do with the other outcome. You know, talking about heads and tails. There's no such thing as being heads and tails at the same time. You know, it's either heads or tails. So those two events are mutually exclusive. These two outcomes are generally referred to as success or failure, success and failure. So an example of that in basketball, success would be considered making a shot. Failure would be considered missing the shot. All right. All right, experiments in which only two outcomes are possible are referred to as binomial experiments, provided certain criteria are met. And of course, we're going to look at those criteria in a second. Buddy, hold on. Buddy, holding on to black. Good. All right. So the criteria for a binomial experiment. An experiment is said to be a binomial experiment if, one, the experiment is performed a fixed number of times. So each repetition of the experiment is called a trial. The trials are independent. That means the probability of one does not or is not affected because another one has occurred. So in other words, those events, those trials, one happening does not affect the probability of another one happening. We talked about independent versus dependence previously, chapter 5. For each trial, there are two mutually exclusive outcomes, success or failure. Remember, you either make a shot or miss a shot. Can't be both. And number 4, the probability of success is the same for each trial of the experiment. All right. But it's still holding on to purple. All right. So notation that's used in a binomial probability distribution. N is going to be the number of trials of the experiment. P is the probability of success. Write that P a little better. 1 minus P is the probability of failure. So if you have the probability of success, to subtract it from 1, that'll be the probability of failure. And then the number of successes in trials. So that's what X will represent. And X is in between 0 and the number of trials that you have, inclusive. So we'll talk more about that when we put some numbers on it and why that's the case. But the number of successes in trials. Well, you can't have more successes than the trials that you actually perform, right? So if you have 10 shots, let's go back to basketball, you can't make 11 shots if you only take 10 shots. So that's why it goes up to in trials. All right, scrolling up. All right, so set of directions. Determine which of the following probability experiments qualify as binomial experiments. For those that are binomial experiments, identify the number of trials, probability of success, probability of failure, and possible values of X. So I'll give you a chance to write those directions down before we get into the example. All right. So the first one, an experiment in which a basketball player who historically makes 80% of his free throws is asked to shoot 3 free throws, and the number of free throws made is recorded. So we want to know, is this a binomial probability experiment? Mm-hmm. Oh, somebody said something in the chat. LeBron would miss. What? All right. So we have to fit and see if we have if it fits the 4 criteria. So the first question, is there a fixed number of trials? The answer is yes. We have 3 shots. 3 shots. All right. I think LeBron is at 73% free throw shooting right about now. Yeah, he's not having a good year this year. All right. Not free throws, as far as free throws, like I said. Next, are the trials independent? Yes. The fact that you miss or make the first free throw has nothing to do with you missing or making the second free throw. Outside of mind stuff, we're not going that deep. We're just talking about your ability to make the free throw is not going to be, hindered or advanced by you making or missing the free throw. So it's not like the free throw is going to rise if you miss and then be lowered if you make it or anything like that. Nothing changes. Everything changes. Everything stays the same once you shoot that shot. Are the events mutually exclusive? Yes. So you cannot make and miss a free throw at the same time. It's either you made the free throw or you missed the free throw. So those events have nothing in common. I put all the, it should be all the events. I left the events out. All right. And then the last one is the probability of success the same for each shot? And the answer is yes, because the person is historically an 80% free throw shooter. So it meets the 4 criteria of a binomial probability experiment. All right. Oh, that's what the green says. It is a binomial experiment because it meets all 4 criteria. All right, so now they want us to list the number of trials. That's n. N is equal to 3. You had 3 shots. Probability of success was 80%, so that's 0.8. Probability of failure is 1 minus the 0.8, which is 0.2. And then the different options for x. So x equal to 0 means that person missed all 3 shots. If you got x equal to 1, that means the person made 1 shot. X equal to 2, he made 2 shots. And then x equal to 3, that means he made all 3 of his shots. All right. So x is the is the options for the number of successes during each experiment. So make sure we're okay before we go to the next one. All right. Anybody holding on to that? All right. So let's look at B. A probability experiment in which 3 cards are drawn from a deck without replacement, and the number of aces is recorded. All right. So you got to see if it fits the criteria. Is it performed a fixed number of times? The answer is yes. Pulling out 3 cards. Are the trials independent? The answer is no, because it says without replacement. Without replacement means that you do not replace the card that you just picked up. So if you have 52 cards, if you pull out 1 card, now what's left is 51 cards. So now you're changing the probability that the next card you choose will be coming out of 51 cards versus 52 cards. And so you're now changing the probability. So that means the trials are not independent. And that means it does not fit the binomial experiment criteria. All right, questions on that? Questions. All right. Questions? Everybody good? So last one like this. It says according to a recent Harris poll, 28% of Americans state that chocolate is their favorite flavor. Flavor. Oh, that's a good way of saying that, huh? Favorite. All right, so favorite flavor of ice cream. Suppose a simple random sample of size 10 is obtained, and the number of Americans who choose chocolate as their favorite flavor ice cream is recorded. Okay, let me come back here. Scroll up in a second. All right. All right, so we have to see if it fits the criteria. First of all, are the experiments performed a fixed number of times? The answer is yes, picking out a sample size of 10. Are the trials independent? Yes. Someone choosing ice cream or chocolate ice cream as their favorite flavor has nothing to do with the next person choosing chocolate ice cream as their favorite flavor. Are the trials mutually exclusive? Yes. Either chocolate ice cream is your favorite flavor or it is not. You cannot, when you say favorite, favorite means that's the one that's above all. So it's not about just liking ice cream or just liking chocolate ice cream. We're talking about, is it your favorite? It's either your favorite or it's not. And then is the probability for success the same for each? And the answer is yes, when it's 25% chance that the person would pick chocolate ice cream as their favorite. All right. So since that's a yes for all four, this is a binomial probability experiment. Meets all the criteria. So it means we can pick out those other things, talking about what the number of trials are, possibilities for success and all that good stuff like that.
Okay.
All right. So number of trials, 10. Probability of success, 28%. Probability of failure means that would be 72%. And then the possible options for X. 0 to 10. So 0 means that out of your sample size of 10, none of them chose chocolate as their favorite. If you x of x is equal to 10, that means everybody chose chocolate as their favorite. Everybody that you know, all that sample size of 10, everybody in that sample size chose chocolate as their favorite. All right. Questions? Any questions? Before we look at our last thing out of this section. All right. So here we have our binomial probability distribution function. So all of this is the function that we'll use. The red, just those are exponents. So we have n, c, n. Now c is not a variable. That's the combination function. So that c combination function is in the scientific calculator. If you have a scientific calculator, I can show depending on what your calculator is, and I can show you where it is and how that works. And but if you want to figure it out on your own, all you gotta do is Google your calculator. I'm pretty sure there's a YouTube video showing you how to use your calculator. For most calculators, there's something out there that'll show you how to use your calculator. But you will need to be able to use your calculator properly, or use a website, and I'll talk about that in a second. But that's NCN P to the X power times 1 minus P to the N minus X power. So X is a power in N minus X. Those are exponents. All right. N, X, and P goes back to what we said they were initially. X is the number of successes, N is the number of trials, P is the probability of success.
Definitely once I get into the homework, I'll definitely have some questions.
You never know. You might get it and be good.
Hey, I don't know. This right here to talk about PX and C. No, I'm just really noticing, like you said in the beginning of the semester, it's like all plug-in and things like that.
Yep. Just
a lot
need to
more
know.
reading.
Yep. Just really need to know how to use it and what it means, the application of it. Yep.
Right. All right, y'all. We got it.
All right, so let's look at a problem that talks about how to use that. So according to CTIA, 41% of all US households are wireless only households. That means no landlines. In a random sample of 20 households, what is the probability that exactly 5 are wireless only? A is saying 5 are wireless only. So I'll give you a chance to write that down before we look at the given information. All right, so let's go ahead and establish what our givens are. P is our probability of success, 41%, so that's 0.41. Probability of failure, 1 minus 0.41, which would be 0.59. Number of trials is 20. And then X is going to go from 0 to 20. Once again, if X is 0, you want to know what's the probability of when I choose this sample size of 20 that none of them will be wireless only homes. If X is 20, we're looking at, when I choose a sample size of 20, that all of them will be wireless homes. All right, so A, as I said before, A, you want to know what's the probability that exactly 5 out of those 20 would be wireless homes. So you plug it into the formula. Here we have the probability of 5. So N is 20. We said X is going to be 5 for us. 0.41 to the 5th power, because that's X. And then 20 minus 5 here, N minus X. So now, if you have the calculator that allows you to put all of this in at one time, then you can put it in just like that. If not, then you may have to simplify some things first before you start doing work. Like you can go ahead and subtract this, that 1 minus 41, that'll give you 0.59. 20 minus 5, give you 15. And start doing things according to order of operations. But there are websites that if you were to Google binomial probability distribution function, that they will, all you have to do is put in key things like, this key information right here, and it'll give you everything that you want. So, and you don't have to go to a calculator. So, maybe next class I can find a website that show you that, and we can, look at how to do that. But right now we're trying to get through the notes. So we'll just stick with the calculator work right now. So you will put this in the calculator, and that would be 0.0656 or 6.56%. Now, remember we talked about before how MyMathLab may present an option for your answer. So notice in this case, it says in 100 trials of this study. And so I basically said that means that if we survey 20 households 100 different times, that's what it means by 100 trials. So in 100 trials of this study, we would expect about 7 trials to result in 5 households that are wireless only. So where did they get 7 from? They took that 100 and multiplied it times the probability that we had, which was 6.56. And that's why they say about 7. So whenever they say this number right here, 100 trials, if they said 1,000 trials, then they could have said, multiplied this by 1,000, this percentage by 1,000, and so on. So just check that number, take this number, multiply it to your answer, and that should be this right here. And that'll let you know if you have, which one to pick. All right. So make sure we're good before we go to the next one. All right, any questions before we look at the next one? All right, the next one, B, probability of fewer than 3 are wireless only. So you're talking about X being less than 3, so that's 0, 1, or 2. So what you would do is find each one of those probabilities individually, 0, 1, and 2 individually, and then add them together. So that's what I did right here, setting those up individually. With X being 0, then X being 1, and then X being 2. All the other numbers stay the same. X is 0, 1, and then 2. Then you get those decimal values for each. 0.000026, 0.000363, 0.002397. Add those together, you get 0.0028. And then my math lab let you know to what decimal value they want the answer, or if they give you those words like we just finished mentioning. All right. Questions? Any questions?
No, that definitely looks a little bit simpler than before.
Well, see, it's just that you're seeing it for the second, third time. You know, you processing it better. That's all.
Expert now at this point, you know. Okay. Mr. Tucker, also I have a question that I've been wanting to ask you since the beginning.
Hmm.
So next class, I'm going to turn my camera on because I feel bad.
Hmm.
Okay. I don't want you just sitting there staring at like black screens. I feel bad every time I get on. So next class, I'm going to brush my hair. We in there. Okay.
Okay.
Yo, anybody else with me? Because I don't know, it's a bit weird. So it's just right out the rest of the semester and come to class, I guess, you know?
Well, I appreciate it.
Yeah, because I don't know how it feels for you. I don't know. But I'm just like, damn, I wonder how he feels about it. I don't know. So I'm just going to do that. Calm down.
All right. Sounds good.
Okay, y'all. Done. Bye.
All right. So looking at C. Remember before we did, and the last one we did less than 3 or fewer than 3 are wireless only. Here we're looking at least 3 are wireless only. So that means 3 is the smallest number, and you're talking about going all the way to 20. So, you're talking about P, or the probability of 3, probability of 4, probability of 5, all the way to 20. We don't want to have to do that if we don't have to. So now the fact that we found this one previous means that we can take that and subtract that from 1 to find the opposite. Remember your complement rule. We know what's the probability of being less than 3. So now if I want to know the probability of being 3 or greater, I can subtract the probability of being less than 3 from 1, and that will give me everything else. Now, if you didn't have that, then you would have to find each one of them individually, just like we did the previous one. Or, like I said before, have a website Apple calculator that you can use in order to be able to find it all. And so, once again, like I said, next class we'll probably take some time out and see how we can do that. All right. Questions? Any questions? All right. I think this is the last one. Number of households that are wireless only is between 5 and 7 inclusive. So you're talking about X being between 5 and 7, being 5, 6, or 7. So find each one of those individually, 5, 6, and 7. And probability of each. Add them together, get 0.3381. All right, questions? Any questions? Any questions?
No. Definitely the anxiety though to go in there and do all it, but it's okay.
Yeah.
And we have the test review for 5 and 6 up, right?
Yes, that should be up already. Mm-hmm.
Okay, cool.
So, next class, like I said, is open for you guys to ask whatever questions you want.
Okay.
And then next Thursday, we'll be looking to do this test. You know, try to do your best on it.
Yeah.
And then, like I said, if not, or if you want to take another shot at getting a better grade, that opportunity will be available to you sometime after we take that test.
Awesome.
Anything, anybody, before we close out, go into the weekend?
No, I'm gonna hang back. I don't even know if anybody else is here with us. Like, is anyone else here?
Yeah, they
I'm
in there.
here.
Yeah, we have people in there. Yeah,
Hey,
I'm
there
about
it is. Okay, the
I'm
hamster
very
free.
tired.
Oh, there. Okay, cool. It's all good.
to say.
Okay, cool.
All right. So if you guys are good, then I'm good. You guys have a great weekend. Be safe. I'm going to help her out, try to help her out with this My Math Lab account. Not necessarily questions, but she has some account issues. So you don't have to stay back for that. So I'll see you guys next week. Be safe. Take care.
Awesome. Bye, guys. Have a good day.
Thank you guys very much.
All right. Take care.
Hi guys, have a good weekend.
All right. You do the same.